Hey, Calc students, welcome back for another free response question from an old AP exam. Today is AP Calc AB, the year 2015, and this is question number 6. So this year's question here, number 6, you very quickly can conclude it is a differential equation style, and it's also a differential equation that is not solvable because it's has multiple variables that cannot be separated, but we can still manipulate it to some degree. So let's see what we're given. Consider the curve given by the equation y cubed minus xy equals 2. It can be shown that dy dx, or the derivative, is equal to y over 3y squared minus x. So, first part, write an equation for the line tangent to the curve at the point -1, 1. So, upon first reading that, you might be wondering if it's as easy as it sounds, and it is. All they're wanting you to do is write the equation of the tangent, which is a common request in calculus class. And you can always go point-slope or slope-intercept, but in either case, we're going to have to write the equation of the tangent. So they nicely give us the coordinate -1, 1, so there's the x and y value we're going to need. So all we're going to need to know is the slope. Well, this is part of the question. Do you know that a differential equation is also slope? So believe it or not, many students don't realize that differential equations are derivatives, which are slopes of tangents. So dy dx is equal to, according to the given question, we've got y over 3y squared minus x. So we just have to evaluate that at the coordinate they're asking for on this question, which is at -1, 1. So let's go ahead and substitute that in here. And I'm going to use this notation of dy dx. I'm going to draw a vertical line, and I'm just going to put -1, 1 in there. And so evaluated there, my numerator is just going to be 1, and my denominator is going to be 3 times 1 squared, which is just 3, and then I have minus 1, so it looks like I have 1/4. So there is my slope value of 1/4. So if you wanted, you could finish this already with slope-intercept, or point-slope, and you could say, well, y minus 1 is equal to 1/4 x plus 1, and that would be an acceptable solution. But if you prefer y equals mx plus b, you could say, well, it looks like I'm going to have my slope here is 1/4, and then I'm going to sub in my x and y values, so it's 1 is equal to actually -1/4 plus b, and so your y-intercept is equal to 1 plus 1/4, or 5/4. And so if you prefer this style, you would say y was equal to 1/4 x plus 5/4. So either one is acceptable, your choice, but there it is, write the equation for the line tangent to the curve at the point -1, 1. Very, very basic question here. All right, part B. Find the coordinates for all points on the curve at which the tangent line to the curve at that point is vertical. Okay, well, let's think about that for a second. If a line is vertical, that would tell us that the slope, so if this is my tangent, I have a vertical tangent here, that would tell me that my slope, depending on your teacher, that would mean my slope is, some teachers would say it's undefined, some teachers might even say it's infinite. It just depends on the lingo you're used to. But vertical tangents mean that it's so steep it's not measurable. Technically the slope is infinite, but the reason it's undefined is you wind up with a 0 in the bottom. So that's the key to this. You have the formula for the derivative, and so how do you make the formula for the derivative undefined? That's the secret. So this a little bit overlaps with finding a critical number. So if you think about it, it's like finding critical numbers when the derivative is undefined. So for the sake of space here, I'll just write this part over here. So here again is my slope, which was given in the problem. So dy dx is equal to y over 3y squared minus x. So the question is, when is this thing undefined? Because when it's undefined, my slope is undefined, which means it's vertical, it's infinite. Well, fractions are undefined when denominators are equal to 0. So you would look at this and say, oh, well, when is 3y squared minus x equal to 0. Because if my denominator is equal to 0, then this whole slope here will be undefined, which implies it'll be vertical. So I have a little work to do here. And the problem is you have two unknowns and just one equation. And so at this point you might think, well, I guess I could add the x over, so I'm kind of stuck at 3y squared equals x. I could divide by 3, root both sides. It's not helping really. I'm trying to solve for a value and I have two unknowns. Well, if you think back to algebraic principles, when you have two unknowns, you have to have two equations, otherwise you're stuck. And so you might kind of feel stuck right here, but then go back to the original question. The original question actually gives you a second equation, and it says y cubed minus xy equals 2. Well, there's your second equation. So I have one equation, 3y squared equals x, and I have the second equation from the problem, which is y cubed minus xy is equal to 2. And so x is equal to 3y squared. I'm just going to substitute that in here. And this kind of is more of an algebra concept than, it's really an algebra question more so than a calculus question. Understanding that slope is the derivative is the slope of the tangent is really the only calculus part of this. So now I'm going to put in the 3y squared here. So I get y cubed minus 3y squared, putting that in for x, times y is equal to 2. And that's going to lead to y cubed minus 3y cubed is equal to 2. And so I'm running out of room here. I think we'll go up here. So I wind up with negative 2y cubed is equal to 2. So negative 2y cubed is equal to 2. Y cubed is equal to negative 1. Cube root both sides, and I get y is equal to negative 1. Okay? Now the original question said find the coordinate of all the points. Well, I've got y is equal to negative 1. And so if y is equal to negative 1, I can just put that in there. And so y negative 1 squared is 1 times 3 is 3. So this would tell me this would also occur at when x is equal to 3. So if you want to write that as a coordinate, this is occurring at 3, negative 1. Okay, so again, the question just says find all the points in which the curve, in which the line tangent to the curve is vertical, and you have to know the derivative is the slope of the tangent. 1 is the formula for the slope of my tangent undefined. When the bottom is 0, just solve it. Then a little substitution from having two equations, two unknowns, and we get to here. So 3, negative 1. Okay, now part C. Only 3 parts to this question. It says evaluate the second derivative, d squared y over dx squared, at a point on the curve at x is negative 1, y is 1. It's actually the same coordinate. They wrote it there. Now why they chose to rewrite the coordinate as x equals negative 1, y equals negative 1, no good answer there. But we have to find the second derivative and then evaluate it. So we better start with the original. So dy dx is equal to y over 3y squared minus x. So they want you to find the second derivative. Oh, so I'm going to put brackets around this, and I'm going to put a d dx on this. Now, initially, when you look at this question, you might kind of think this feels a little bit easy. Feels like it's on the easy side. And it is at first, and you think, well, equation of a tangent, that's not that bad. Then this one, once you understand the concept here of being vertical, it was kind of algebra heavy, not much calc. And now we're here taking the second derivative. And then you notice, oh, I have a quotient rule. And then as we do the quotient rule on this, you're going to see it's a messy quotient rule. So this is one of those questions that's very tedious with lots of opportunities to make a silly mistake. So you got to be really careful here. So my second derivative here, so I've got d squared y over dx squared. But now I've got a quotient rule, and I've got some implicit differentiation within the quotient rule. So you got to really be careful here. So my variable of my operator is x, but my numerator is y. And so every time you take the derivative of y, you're going to have to generate a dy dx. So let's go through here. Derivative of the top technically is 1 times dy dx, because my variables don't match. Derivative of the top times the bottom 3y squared minus x, minus the top, we're back to y, times the derivative of the bottom. Now, derivative of the bottom, well, I've got a 6y, but my variables didn't match, so I need another dy dx right here, minus 1, all over the bottom, 3y squared minus x, the quantity squared. Okay? Now, you'll notice that this not just is a messy derivative, but I have two dy dx's within there. Now, because I'm evaluating this, it says at the coordinate negative 1, 1. What you want to notice is that we actually already did that for the first question we found this. And in fact, if you notice right here, the derivative evaluated at negative 1, 1 was right there. It was actually a quarter. So I'm going to replace dy dx, those two places, with 1/4. And then I'm also going to put in x is negative 1 and y is 1 for all of these places and see what we get. So again, lots of tedious substitutions here with lots of opportunities to make a careless error. So let's see if we can avoid that. So the first one, I don't need to write the 1, but the dy dx is a quarter. And then I get 3 times 1 squared, which is just 1, minus a negative 1. And then I've got minus, and I've got 1 again out front for the y, times 6 times 1 for my y value, and then there's my other quarter, minus 1. And then on the denominator, this is just going to be 3 times 1 squared, which is 3, minus minus 1. And then we're going to have to square that. Okay. More simplifying here. So it looks like we have a quarter. And we get 3 plus 1, which is 4. That's going to drop out nicely. Minus 1 up front we don't need to worry about, but 6 over 4 is 3 over 2. 3 over 2 minus 1. So 3 halves minus 1 is a half. And so I have minus a half right there. So it looks like that's what we're getting there, so that can be a little shorter. And then on the bottom I got 3 plus 1 squared, 16. Okay, and then what do we get here? We get 4 times a quarter is 1, so we get 1 minus a half over 16. Well, that's going to be 1/2 over 16. Let me clean that up a little bit here. 1/2 over 16, move that up, and you get 1 over 32. Okay, and that's the answer. So this one moved pretty well, and not maybe on the easier side, but a little curveballs in there. So letter A, very doable. Letter B, understanding the concept here and knowing your substitution. And then C was not very difficult, but you just want to make sure that you're paying attention to detail here and carefully working through this to get that value. So there it is, AP Calc AB 2015, question number 6, differential equations. Thanks for watching. We'll see you next time.